So, in previous video, we discussed about Ohm's law and time varying magnetic field. So, uh, mm, in this session, we'll discuss about properties of RLC components and their units also. See, first we'll discuss about resistance. First, we'll discuss about resistance, resistor, inductor, capacitor. So, before going to discuss about resistor, inductor, and capacitor, first, anyone have 5 members family? 5 members family. See, 5 members family is nothing but father, mother, brother, sister 1, sister 2. If you have 5 members family, then it is applicable. Here father is nothing but voltage, mother is nothing but current, brother, resistor, sister 1, inductor, sister 2, capacitor. See, here father and mother, these are source elements. Source elements. Always, father and mother always gives the money to brother and sisters. Similarly, here voltage and current, these are the sources. Always gives the energy to, always gives the energy to, always gives or deliver energy to, energy to outside. Outside means these components, RLC components. So, voltage and current sources always delivers the energy. That's why voltage and current sources are known as active elements. What are those? Active elements. Active means always deliver, giving. But coming to RLC components, these are absorb energy from outside. Always absorb the energy. So RLC components always absorb the energy from the outside, means source. See, here resistor, inductor, capacitor. See, here voltage, which may be DC, voltage, which may be DC or AC, DC or DC or AC. This is the representation of DC voltage source, positive, negative. But coming to AC, sinusoidal. This one is V of t. V of t. It is varying AC. It is varying with respect to time. Already we discussed electric field. See, here it is constant. It is not varying with respect to time. DC is representing with positive, negative. AC is representing with sinusoidal, which may be voltage or current. If it is voltage, simply V for DC and V of t is for AC. If it is current, current is representing with I. Current is representing with I. So here I, which may be AC or DC. DC for AC, simply I can representing with time varying current. Time varying current. So these are the sources. Voltage and current sources. These are always giving the energy to outside. That's why these elements are known as active elements. These elements are known as active elements. These elements are known as active elements. But coming to resistor, inductor, and capacitor, these elements are always absorbs the energy from source. See, coming to resistor. Resistor is nothing but brother. Inductor is nothing but sister 1. Capacitor is nothing but sister 2. See, after completion of the month, father will send the money for pocket money, for pocket expenditure. See, what brother will do? Immediately he will spend the money in, where? In a restaurant or for roaming, he will spend the money. But coming to inductor and capacitor means sisters. Sisters, brother is enjoying person, but sisters, these are saving the money. Good fellows. Brother is brother is enjoying person. See, brother always spend the money. Brother always spend the money. But sister one, sister two, these two fellows are good fellows. Always saves the money. So similarly here, resistor representing with, this is the symbol resistor, and this one is inductor, this one is capacitor. Representation is RLC. What is the unit of resistor? Ohms. Unit of resistor is ohms. This is the symbol. Unit of inductor? Henry. Unit of capacitor? Farad. Unit of capacitor is farad. What is the unit of voltage? Volts. Current? Ampere. Current is ampere. Okay. Say, what is the first property? What is the first property which does not allow sudden, which opposes flow of current, which opposes flow of current, means V equals to IR. From this, R equals to I equals to V by R. I equals to V by R. Suppose for constant voltage 10 volts, if R equals to 2 ohm, what is the current? I equals to 5 ampere. If R equals to 4 ohm, I equals to 2.5 ampere. If R equals to 5 ohm, what is the current? I equals to 2 ampere. Means as the resistance value increases, what is the current? Decreases. So what is the first property of resistor? Which opposes flow of current. So this is first property. Second property, which dissipates energy in the form of in the form of in the form of heat, which dissipates energy in the form of heat, okay. So here heat energy W equals to I square R into T. Brother always spending the money. Brother always wastes the money. Means resistor which dissipates energy in the form of heat. But coming to inductor, sister one. Here, what is the first property? Which does not allow sudden change in current. Current. Means V equals to L into di by dt. So here current is varying with respect to time. So which does not allow sudden change in current. Which does not allow. Here which opposes the flow of current, but here which does not allow sudden change in current. And another property here, what is the inductor? Which stores energy. Resistor is brother. Brother always dissipates, always wastes the money. But inductor, sister. Sister always saves the money, stores the money. Means stores the money in, sister one stores the money in, saves the money in Canara Bank. Sister two saves the money in SBI. But ultimately, sisters are saving the money. Similarly, here, inductor, we stores energy in the form of in the form of, we stores energy in the form of magnetic field. We stores energy in the form of magnetic field. We stores energy in the form of magnetic field. So that equals to W equals to integral Li di by dt. Li di by dt into dt. Integral p dt. So this is about inductor. So coming to capacitor, say here which does not allow sudden change in current for inductor. Say capacitor does not allow sudden change in voltage. Sudden change in voltage means I equals to C into dV by dt. Next, we stores energy in the form of electric field. We stores energy in the form of electric field or voltage. We stores, coming to inductor, we stores energy in the form of magnetic field or current. Here we stores energy in the form of electric field or voltage. Anyway, inductor, capacitor, both are sisters. Always stores the money. Similarly, saves the money in different way. Here also stores the energy in different way. We stores energy in magnetic field, we stores energy in electric field. So what is the formula? Integral C into V into dV by dt into dt. So this is the formula for energy. So from this, if you can understand V equals to IR, V equals to L into di by dt, I equals to C into dV by dt. See here, for resistor, I will apply DC only, DC or AC. I can apply here DC or AC. But for inductor, always I should apply AC. For capacitor, always apply AC, not DC. So which is suitable for AC only. But for resistor, you can apply either AC or DC. So resistor concept we will discuss in DC circuits. Inductor and capacitor, these are coming under AC circuits. So parallel I will cover DC circuits and AC circuits. So for inductor and capacitor, which type of supply I am applying? AC supply. Alternating voltage. So coming to resistor, here V equals to IR. From this, what is current? I equals to V by R. This is another formula. So here V equals to L into di by dt. So from this, what is current? I equals to 1 by L integral V dt. How I am getting 1 by L integral V dt? From this, how can I rewrite this equation? V dt 1 by L is equals to di. If you apply integration on both sides, from this I equals to 1 by L into integral V dt. Similarly, V equals to 1 by C integral I dt. So this is the voltage equation. So these are the voltage, current and energy relations for RLC components. Clear? So next we will discuss about, see, this is the table. V equals to IR. For the same thing, current I equals to V by R. Power is nothing but VI. Power is nothing but V equals to VI. Suppose if you take V equals to IR and substitute here, IR into I square R. Suppose if you substitute I is with V by R, you will get V square by R. So these are the formulas for power, for resistance. Similarly for inductor, V equals to L into di by dt, I equals to 1 by L integral V dt. So what is the power? If you substitute V here, Li into di by dt. If you substitute I here, 1 by L integral V square dt. Similarly for capacitor also. Energy. Energy is nothing but integral P dt. You can substitute any power formula here. Then you will get, these are the energy formulas. So this is about relations of circuit elements, properties and units. So what is the unit of voltage? Volts. What is the unit of current? Ampere. What is the unit of resistor? Ohms. What is the unit of inductor? Henry. What is the unit of capacitor? Farad. Next, this is inductor. Suppose I want to find out inductive reactance. Inductive reactance, where XL equals to 2 pi FL. So here inductive reactance unit is ohm. Inductive reactance unit is. Next, capacitive reactance. So XC equals to 1 by 2 pi FC. So what is the unit? Again, ohms. So inductor unit is Henry. But what is the inductive reactance? Unit is ohms. Capacitor unit is farad. But capacitor reactance unit is ohms. So this is about relations of circuit elements. So till now, if you have any doubt, you can ask and you can share your doubts. Now we'll discuss about some problems based on RLC components. See, suppose this is R. Right. So what is the resistance? R equals to V by I. V means 5 volts by 5 amperes. One more. Like this you can find out. Suppose inductor 2 Henry and applied voltage should be time varying. So V of t is equals to Vm sin omega t. Means let us 10 sin 50t. Means omega is 50. From this, what is the, you can find out inductive reactance. XL equals to 2 pi FL. 2 pi F is nothing but omega. 2 pi F is nothing but omega. So omega L. Where omega is indirectly has given 50 into inductor is 2 Henry. So 100 ohm. That is inductive reactance. Similarly, if you take capacitor 2 millifarad, let us, and same voltage applied here, V of t is equals to 10 sin 50t. So from this omega is equals to 50 sin omega t. You can compare. Omega is 50. So Xc is equals to, how you can find out capacitive reactance from this? What is our target? Find out XL, find out Xc for this. So Xc is equals to 1 by 2 pi Fc. 1 by 2 pi F is nothing but omega. 1 by omega C. So 1 by omega is nothing but 50. Capacitor is 2 millifarad. 2 into 10 to the power minus 3. So what is the resultant? 1000 by 100. Means 10. 10 more. So this is about calculation of inductive reactance and capacitive reactance. He has given time varying supply, inductor value, capacitor value. Okay. So this is about RLC components. Next we will discuss Kirchhoff's voltage law and Kirchhoff's current law. So what are the Kirchhoff's laws? Kirchhoff's laws. Kirchhoff's laws are KCL, KVL, KCL, KVL. So that we will discuss in next video. Okay. So in this video we discussed RLC components, its properties, relations. Okay. So in the next video we'll discuss about Kirchhoff's voltage law. And if you had any doubt, you can share your doubts. Okay, thank you.